Hi, I'm Jay Varma, and welcome to Thermometer. On this channel, I check the temperature of health in the US and around the world and give you expert insights on infectious diseases and public health. And today is our weekly episode of Inside Outbreaks. And on these episodes, I review the latest outbreaks of infectious diseases occurring here in the US and around the world that you need to know about. And I do that with my friend and colleague, Jon Epstein, a veterinarian, virologist, and disease ecologist who, like me, has spent his career tracking dangerous infectious diseases across all corners of the earth. Thanks, Jon, for joining me today.
Hi, Jay. Thanks for having me. It's great to be here.
Yeah, it's always great to sit and talk outbreaks with you. So, and for viewers out there, one of the things we do is we kind of like just exchange some messages, a couple of days before this episode to try to think about what are some stories that we think are out there that are kind of important and pressing for us. So, and for those of you who are interested in bird flu, of course, we have a separate series dedicated just to bird flu. So today we're going to talk about a disease that is, rapidly becoming part of our regular daily news cycle, which really shouldn't be. The U.S. officially declared measles eliminated in the U.S. in 2000. And what that means is basically that the only cases of measles that you should see in the U.S. right now are cases in people who travel around the world, are exposed, and for whatever reason are not vaccinated or not fully vaccinated, and they come back and those are cases. So in an ideal world, that's the way the U.S. should be. But what we've seen right now is that an outbreak starting in West Texas at the beginning of this year or the end of last year has now spread across the United States. So far, there are 483 laboratory confirmed cases in 19 different states across the United States. And one of the things we wanted to talk about today is a question that Jon actually asked me earlier, which is, how do we know these aren't imported cases? And one of the ways that we can find this out is by patients who get sick, have their specimens collected, and having those specimens go to a special laboratory that can check the genetic sequence and try to say, hey, this case is linked to the Texas outbreak, as opposed to linking to somebody who traveled in Europe or in Asia and was exposed somewhere else. And one of the things we wanted to talk about today is that, unfortunately, the World Health Organization is now reporting about outbreaks here in the United States and reported about how the Texas outbreak has now been genotypically linked. That means the virus has clearly been shown to extend and be responsible for cases in New Mexico and in Kansas. And almost certainly it's responsible for cases in other states as well. So I wanted to turn it to Jon to help give our viewers out there, a little bit of information about, what is genomic sequencing and why is it kind of important in situations like this? What are the ways that we can use it to maybe trace viruses, and how is it done, and what are some of the limitations of this approach?
Yeah, that's great, Jay. And I got to say, as a public health physician, this must be incredibly just distressing to you to see totally vaccine preventable disease that we had eliminated for all intents and purposes crawling back into, our consciousness, that we just shouldn't be seeing cases of measles.
Yeah, and actually for you, Jon, my kids are now grown and out of the house, but you have young kids at home, so this must be a concern for you and your family as well.
Well, my kids get fully vaccinated and we keep up with all the recommended vaccines. But, I'm really aware of the fact that when people, decide not to vaccinate or lapse, that gives viruses an opening to start spreading. And that's really what seeds some of these outbreaks. But you asked about, genotyping and what information that tells us. And it's important to understand how viruses work to help explain why looking at the genetics can tell us something about their spread. And that is that viruses enter into bodies, they enter into our cells, and they take over our cells to make more virus. And in the process of making more viruses, they basically replicate, they make clones of themselves. And the DNA, or in some cases like measles, viruses are RNA-based, a different type of genetic material. In the course of making those copies, sometimes there are errors, there are writing errors, just like if you had to take a Word document and manually transcribe it thousands of times, you'd make mistakes in the process, even if you were really careful at checking that. And those mistakes, just like when viruses replicate, can lead to little alterations, or what we call mutations, in the genetic code. In the case of measles, this is one of the most contagious viruses we know of. It spreads like wildfire. But from a genetic standpoint, it's fairly stable. We don't see lots of big changes as the virus replicates and spread. There's enough change that if we look at the genetics of measles, let's say in Europe or Asia, it might look a little bit different than the genetics of the measles virus we see now in the United States in these outbreaks. That's one way we can tell whether a case of measles came from outside the United States or locally. The second thing is, in an outbreak situation where you have cases that are connected to each other, transmission going on locally, a local cluster, the genotype of those viruses is identical. There hasn't been enough replication to really cause any change. And that helps us epidemiologically link those cases together. This is an identical virus among a cluster of cases, hundreds or even thousands, that tells us that spread is happening locally and it's not introduced as a different lineage from somewhere else.
Yeah, no, and that's really the sort of the key education point for people to realize here is that this is just one more piece of the types of detective work that we can do to track measles cases. But the concern that I have is, so I talked earlier that we have 483 confirmed cases of measles in the United States. But there is a real challenge here, which is that not every kid with a fever and rash is probably getting tested. Particularly in a lot of these communities where there are low vaccination rates, there's also a lot of suspicion about the healthcare system. And we're going to talk about another aspect of that later on in this episode. And that suspicion of the healthcare system will lead people to not bring their patients not bring their kids in maybe to get tested, or discourage a doctor from actually doing a testing because they may also say, well, look, it's obvious you have measles. Why do we need to test it? And so I really think it's kind of an important message out there. If you're involved or know people who might have measles or anything, it's really important to get tested, because one of the things we can do from those test results is not only we track the number of confirmed cases, we can also get a better sense at a public health level about how they might have gotten infected and whether this is all part of this, outbreak that started in Texas or whether it came from somewhere else.
That's right. And it's important to mention too, that right now, the majority of cases that we are confirming in the United States are from people who were not vaccinated against measles. Now, there are a few who have a history of vaccination, but maybe it wasn't the total dose of vaccination. Maybe they only got one of the two shots, or maybe they got both, but their immunity waned. And I have to say, just a quick personal anecdote is that we always learned that measles vaccinations, you get them as a child, and then it gives you lifelong immunity. But that's turning out not always to be the case. And just, sharing a little personal information is I've been vaccinated as a kid. And a few years ago, I was traveling to another country where measles was still prevalent. And I checked my titer, and it turned out that my titer had dropped below protective levels. I wouldn't have known that if I hadn't tested, but I had gone under the assumption that I was all set. So I got a booster and my immunity's back and fine. But I think worth mentioning that if in doubt, it's something you can check. You can ask your doctor to test your titer and know whether you have protective immunity or not.
Yeah, no, John, this is an important point. And we struggle with this a lot in public health, right? We want to build confidence in the safety and the effectiveness of vaccines, but we also have to give people information that nothing we do in life is perfect, right? And there's a really interesting understanding, measles immunity, gets to one of the biggest challenges that we face also when new vaccines are introduced. We face this during, when the rollout of the COVID vaccine. People would always say, well, how long is this going to protect me for? And I kept having to answer, and I wasn't trying to be sarcastic or humorous. I was like, I don't have a time machine. Like humans didn't design the human body. And I have no way of knowing how long your protection is going to last unless we follow people out over time. And that's exactly what happened with measles. When the measles vaccines were first developed in the 1960s, it was believed that they provided lifelong immunity. And so you only needed one dose of vaccine given 12 months of age or older, because you had to get all of your mother's antibodies out of your system. We thought that protected you for life. And then in the 80s, you started to see these large outbreaks in the United States. And the theory is that people, because there was still measles going around at a lower level, throughout the 70s, that a lot of people were effectively boosted. They got a second vaccine dose they got a second immune boost from the virus that was naturally circulating. And so that's why it felt like it was lifelong. But once you dropped, measles in the community to a lower level, we discovered that, in fact, in some people, that measles vaccine that you got at age of 1, you needed a second dose. So that's why right now the childhood vaccine schedule is to get 1 dose at about 12 months of age or a little bit later, and the second dose usually between the ages of 4 and 6. But Jon, as you pointed out, it is certainly possible for a small percentage of people to not retain that protection. And in those people, one option, Jon, is to do what you did, which is to get a laboratory test. Most medical providers like myself will simply say, you know what, the vaccine is so safe and effective, let me just give you another dose.
Yeah. And I certainly would have accepted that if the doctor had offered it. But, being who I am, I wanted to know exactly what my titer was and see where it was at. And I was actually surprised to find that it had dropped that low. So
exactly. Yeah. And we'll talk about this probably in some other episodes. I've had the same issue with hepatitis B vaccine. And so, yeah, there are certain situations, particularly for these types of infections, where it is really important to guarantee that you retain your immunity.
Yes.
I want to switch gears a little bit to another emerging infection that has gotten a lot of news lately. It's not obvious to me that there's been anything new that's occurring, but I've seen several articles from local newspapers local newspapers like the LA Times about reporting in California. I've seen reporting in Georgia. I've been reporting in New York State about a fungus called Candida auris that has been surging essentially in hospitals in the United States. And I want to give people just a little bit of background about this. This is a fungus that, we as people who work in clinical and human health medicine had not ever seen as a common organism until sometime in the past 10 to 15 years. And it's unclear because it appears to have emerged spontaneously in different places around the world. And what makes this such a serious threat is that this is a fungus that when it gets into the hospital system, people, healthcare workers, even visitors to the hospital can carry it on their body, or it can be carried on instruments somewhere. And then if you are a patient in that hospital, particularly if you have any type of plastic in your body, an IV in your body or a catheter to drain your urine, any type of other device, you can be at very risk of having this fungus travel essentially, from the environment or from the skin of somebody else into you, and it is incredibly deadly. It appears that it causes death. The death rate is somewhere up the rate of 40% because these are also people who are in the hospital with other reasons. And so it's really important, I think, for people out there to look up and try to understand a little bit more, because if you or a loved one is going into hospital, this is something that, needs to be watched out for. There need to be very safe precautions that are taken. And what I wanted to turn back to you, Jon, is why are we seeing organisms like this evolve in the environment? I think that you and I are one of those people that are passionate about the connection between the environment and animals and humans. But we also see how the way we use antibiotics, the way we disturb our ecology, can also give rise to new pathogens. So, I'll give a little bit of insight into what I know about Candida auris in a moment, but I first want to turn it back to you, Jon. And how does changing the ecology of the way we live lead to new diseases emerging?
Well, that's a big question, but in the context of things like fungi, and listen, I'm a virologist, not a mycologist, so I'm going to do my best here, but I will say in the animal world, fungal infections have been absolutely devastating. Not only the ones that can infect people or our pets that are, sick or otherwise immune compromised, but wildlife. We have seen fungal infections absolutely decimate amphibian populations around the world. And we have seen fungi invade bats and decimate our bat population here in North America. And what we really understand about fungi is, number one, they can survive in the environment. So they don't require a living host like an animal or a person to replicate the way viruses do. Viruses don't survive very long in the environment, but fungi do. And so they have adapted and evolved to certain conditions. There are some fungi who like cold, dark, damp environments, others slightly warmer, but they can be very temperature specific. And you kind of alluded to this, but one reason that we see a limited range of fungal infections that invade people or animals is that they have to be adapted to our body temperature. They have to be able to live in our environment. And it's often when we're immune suppressed or immune compromised that fungal infections can get from the environment and successfully cause an infection. think about things like thrush when we're on cancer therapies that are immune suppressive. But, as to how that happens and what kind of ecological change, well, certainly environments are changing because the earth is warming. And so living organisms are adapting to that, just like we're trying to, and that can affect adaptation of fungi. And we're also changing the interactions we have with the environment around us. We're, in some cases having more contact with animals, more contact with environments that used to be forested, that used to be secluded, and now human populations moving into those environments. And so there's just more opportunity to come in contact with some of these environmental microbes that we might not have had as much interaction with before.
Yeah, and the theory that the leading theory that's out there about Candida auris is directly related to what you just said. And just to emphasize this point, it's believed that one of the reasons humans don't get these infections very commonly is, number one, because of the other organisms we have in our body that kind of help keep fungi in check, because we have a microbiome where we have bacteria and viruses that are living in us routinely. But the second reason is this issue about temperature, that the human body is too warm for a lot of funguses to actually grow inside us. And one of the leading theories out there, and this is based on some research that's been done in India and in a few other places, is that it's possible that global warming, which is very gradually warming all the temperatures, whether it's water temperatures or land temperatures, has probably selected for selected for fungi that can actually live in warmer climates like the human body. Right. And so the theory and concern out there is that, Candida auris, this pathogen, may be related and linked to climate change in some way.
Yeah, and we have to look out for more of that, as the environment changes, both climatically, but also, through land use change and the changes in contact between people and our livestock and wildlife. We're going to see more and more different microbes emerging and potentially causing problems to our health.
And this leads us to our last topic, which is, and the theme here has been, you mess with your environment, you mess with you take antibiotics, you do other things like that, then new things that you didn't think about could happen. And these could be very bad things. And we saw this news this week that the state of Arkansas has decided to make a drug, which is normally used to treat river blindness, onchocerciasis, and lice, ivermectin, over the counter. That means anybody can go buy it at a pharmacy in Arkansas. And so, Jon, I'll turn it back to you. Why is it that is there an epidemic of lice or river blindness in Arkansas that we know of?
No, sadly, this is just a case of misinformation and somebody capitalizing on a belief that ivermectin is a potent remedy for COVID, and it just isn't. Ivermectin, from a veterinary medicine standpoint, we use this to treat parasitic infections, worms in animals. It's a great dewormer. We use it in horses, we use it in dogs and cats. It occasionally used in people for the same reason, but it is a drug that is an antiparasitic. It has no known antiviral properties, and there's certainly no data from any clinical trial showing that ivermectin is an effective treatment for COVID infection. So as to why it's available over the counter now, I don't know, but when drugs get misused or overused, one of the consequences potentially is resistance from the organisms it's meant to treat.
Yes, absolutely. And this is, we won't go into it in detail today. Maybe we'll do it another time, but there are all sorts of sort of anthropological or cognitive psychology reasons why, a unfortunate group of people has latched onto this idea that you can take drugs, which we know have no biological effectiveness against this virus, and suddenly decided that this is the cure that's happened. A lot of this is, people, I think, there's this mistrust in the healthcare system, which is leading to low vaccination rates. And it's to people believing that vaccines are dangerous, but taking, drugs that were developed for entirely different reasons is somehow safe. And not only is it safe, but it's also effective. And this, I think, intersects with a lot of sort of conspiratorial thinking. It intersects with this notion of sort of health libertarianism, that I can do my own research, which generally tends to be on YouTube or Google. And that as a result, I can take these pills and they will cure me of all of my ills. And it's really just unfortunate, because it's really preying on people who unfortunately they want to be healthy, but unfortunately it's literally the same way we used to think of snake oil. right? This is effectively snake oil. And what worries me is not only, it worries me several things. One, people are not going to get treated for the conditions they do have, number one. Number two, they could have toxicity. These drugs are not safe to be taken on a regular and ongoing basis like any other drug. You take it for a very specific and indicated reason. And the third is there is the possibility that it could mess with our microbial environment in some way. And so just like you would never have predicted that climate change could lead to an invasive fungus that kills 40% of people when they get it in a hospital, I don't know what widespread use of ivermectin is going to do, but I can predict it's not going to be something we necessarily want.
Yeah, and hopefully there isn't widespread use of ivermectin. I really hope that's the case. But, there's another important point here, Jay, and it's that when we talk about drug safety and how we know what the efficacy of a drug is, what's the right dose, what does it actually do therapeutically, and what doesn't it do, those come from clinical studies that are conducted by the FDA, that are supported by funding from NIH. So on the one hand, we're talking about this drug that has no known ability to, have antiviral properties and fight COVID, but the very institutions that would test for these things and give us valuable data to understand medicines are being dismantled. And so that is a real risk we're at right now, as we take away our ability to test drugs and to discover new drugs, right? When drugs stop working, we have to have the next possible candidate to step in to fight off an infection. And as we diminish our ability to do that research, we leave ourselves very vulnerable to not being able to fight infections in the future.
Yeah, absolutely. And on that note, let's, I hope people, got some useful information today. Obviously we're going to keep tracking all of these stories, particularly, this growing measles epidemic and also how, our environment, the things that we do, we take ourselves, the way we impact our environment, how that's impacting the world we live around us. And in some situations, putting us at risk for new and evolving diseases. So I hope you've enjoyed this episode of the Thermometer. If you did, please hit the like button, please hit subscribe, and look forward to seeing you next week for our next episode of Inside Outbreaks.
Bye-bye.